Okay, so in the last video we created a switch FOP for switching between our different render passes. Now, you may have been asking yourself when we set this up, well, why are we dealing with it like this? Because surely we'd want to render all of our passes at once, not just a single pass. Well, we could, if we wanted, take a different approach in our shader, and instead of using a switch to switch between our different passes, we could output each of our passes as a different variable from our shader, and over on a mantra output driver we could listen out for those variables and send them to different image planes, and if we wanted we could even save out each image plane as a different file on disk, so that when we fire off a single render we'd get all of our render passes rendered out. But the problem with this is that for that single render, all of the nodes of our shader are going to be evaluated, and that means that our render is going to require a lot more memory to render a single frame than it would if it was only rendering a single pass. And because it requires more memory, this could very well mean the difference between a successful render or crashing due to running out of memory. Also, if we then wanted to go in and just render a single pass as opposed to rendering all of our passes, it becomes a little more complicated. We have to tweak a lot of the parameters on our mantra output driver, and things are just a little messy when working that way. There is, of course, an advantage to working in that method, and that is if we had nodes that are shared between multiple passes, and we don't really, this is the only node at the moment that's shared between multiple passes, but later on we may have more complicated calculations that are shared between multiple passes, and if we do have such nodes, then they're obviously only going to be evaluated the once for all of the passes as opposed to being evaluated for each pass that needs them. But while this makes the overall render time maybe very slightly quicker, the fact that to render a single frame requires us to calculate every single pass means that when we're rendering one frame, it's going to take much longer from the start of the frame to the end of the frame, whereas if we're rendering multiple passes, it may take even longer than that to get each of the passes frames, but each individual file that we save out renders quite quickly. And the reason I prefer that over a longer render time and then we get all of our files at the end of that render time is that if we were to crash mid-render, we'd lose each of our passes. And obviously the longer we're rendering for, the more risk there is of crashing in the middle of a render, because if we're rendering and it takes 20 minutes to render one set of passes, and if we crash 19 minutes into that, instead of having maybe all but one of our passes complete for that frame and just that last pass crashed and we just have to re-render, we'd risk having to re-render all of the passes for that frame with the variable output method. And obviously we want to minimize the render time as much as possible, and so I feel personally that the risk that you have of having a really long render time for a single frame, especially as, you could run out of memory and crash using that method, I feel that that risk is far too great, and therefore I prefer switching discretely between passes and then working at a higher level to manage how we can render all of those passes at the same time. So we are going to need an alternative method to allow us to render passes separately, but at the same time manage them in such a way that we could render all of them one after the other if we wanted to. And our switch FOP, with that parameter that's driving the switch FOP up on our asset, our render pass parameter, they are the beginnings of this system, and they give us a very simple way to specify just a single pass that we want to render. So if we can find some way to easily drive that parameter, then we can quickly render multiple passes in succession. Now currently we'd have to dive down to the material parameters when we want to specify a render pass, and this really isn't very convenient because by the time we're working with wanting to render different render passes, we're most likely not working at the shader material level anymore. We're most likely working at a higher level, our scene's in place, we're probably wanting to be working in the output context, working with mantra, render output, operators and the likes. So we're not really going to be working down at the material level, so we don't have to jump down to the material level to tweak our render pass, change our render pass. So we need a higher level place to drive our render pass. And the first thing you might think is, well, quite common to use takes in Houdini. We could create takes in Houdini and we could use different takes for different render passes. And this is a very nice high level way of working. So what if we were to set up a series of takes and use those takes to drive our render pass parameter down on the asset? Well, it certainly gives us that high level of control, and it's also not too hard to set up takes, and then we can also set up our mantra output driver to use the current take when it's rendering. Or we could specify a particular take when rendering to specify passes. So that's quite a nice workflow, but we have to consider, well, what would happen if we had multiple instances of our shader? Because each time we create an instance of our shader, we have to set up the parameter on that shader to respond to our takes, and that's a quite tedious, quite slow process. And I mean, even if we wanted to create 3 or 4 shaders, we'd be there a while. If we imagine that on my particular project, I had hundreds of instances of this shader. We really just couldn't manage setting all of those up manually. And I mean, that's just for one file. Imagine now we have multiple shots and we're setting them up differently in each shot. It's just an absolute nightmare if we had to manage setting up our takes to drive all of those different parameters and all of those different instances of our material. So we need some other way of working. So okay, if takes aren't going to work, well, what if we were to create, say, a null, create a null node somewhere and use that to store a render pass setting on? And a null node at a higher level would certainly mean that we're not down working with materials anymore, and we could maybe create an identical render pass parameter on that null, and then we could drive our material parameter with that null's parameter, and surely that gives us a high level place to change our render pass from. But if you think about it, this still leaves us with that same issue of having to connect each new shader instance to that null. Or does it? Unlike with takes, we can set the default value on a render pass to be an expression. So on this parameter on our material, if we can set the default value, instead of being a number, we could set it to an expression, and we could set it up by default to connect to the idea of a render settings node. And here's what I mean. If we jump over to our whiteboard, instead of setting the default value to a number, what if we set the default value to this expression? So we're grabbing the value of a channel, and that channel is explicitly referencing a render settings node, and this can just be a null, in the output context. And that render settings node is going to have a render pass parameter. And why is this useful? Well, if that node and parameter on that node don't exist, the expression's obviously going to just set us to a value of 0. And that's not in itself very useful. However, as soon as we create a node in/out with the name render settings, and then on that node create a render pass parameter and set it up to match how we're expecting our render passes down on our material, the expression's automatically going to grab that value without us having to make any changes to our material asset. Even better than that, if we create new instances of our material asset, they're automatically going to be linked to this node and parameter as well. So we have this one place, and every instance of the shader that we create is going to look at this place to work out where it wants to basically set its render pass to. And that means that we can have hundreds of instances of our shader in our scene, but we don't have to set up each one individually. We don't actually have to do anything on the shader. We just have to set up one node, that is the /out/render settings node, and make sure that its render pass parameter that we create on it matches the render pass parameter that is down on our asset. Now, there may be cases where we want specific instances of our shader to not follow this node, and we can do that as well by simply deleting the expression that gets created by default. So this is a very powerful way of minimizing the amount of work that we need to do to get all of our shader instances following a certain render pass. And another advantage of this is that we can now use something like a wedge drop to loop through all the values of this parameter, rendering out each pass. Or, and this is my preferred workflow, we can drive that single parameter with a number of takes. And note, the advantage of this, of course, is that we have just one parameter that we need to set up to be driven by takes. And again, if we set up new instances of our material asset, we don't have to link those into our takes. They're automatically driven still by this parameter on that node. So we can set up this single parameter to be driven by a number of takes, and that allows us to use a wedge ROP to render each take in turn if we want. We could jump to a mantra ROP, and we could just render using a specific take. We could, if we needed to, set other path-specific settings in the scene, for example, make certain objects invisible, or reassign shaders to certain objects using our takes, just as we would when dealing with render passes outside of dealing with this particular material asset. It's quite common to set up a number of takes and change parameters, especially material parameters, based on those takes. So takes is a very nice way of dealing with render passes. We could also create multiple variants of certain passes, so I could have diffuse lighting and multiple variants of diffuse lighting, or multiple layers where we have different objects visible for diffuse lighting. Really, the possibilities when working with takes are endless. So that is the workflow we're going to be using. We're going to be creating this node, our output render settings null, and it's going to contain a render pass parameter, and we're going to link automatically to that node the render pass parameter of our material asset. We can then drive this parameter with some takes, and then we can automatically render all of our takes using a wedge ROP, or we can specify individual takes over on our mantra output driver. So let's jump over into Houdini and let's start implementing this. So the first thing I want to do is create this node. So I'm going to jump over into Houdini. Let's close out our parameters, and I'm going to jump up to our output context. No nodes in there currently, so I'm going to create a new null, and this null is going to be our render settings null. And I'm going to right click and edit the parameter interface of this node, and we're going to create on this node, well, the first thing I want to do is make these two guys invisible. Fantastic. And then I'm going to create a new integer, and this is going to have the name of renderPass and the label renderPass. Now the channel name, the parameter name, is very important, because if we're going to be referring to it using an expression, we need to know the exact name of that channel. So if you do give this a different name, keep track of it, because later when we drive our material asset with this expression, we need to make sure we are referencing this parameter on this particular node. And we can jump over and set up a menu for this guy, and as long as we make sure that this menu corresponds to our parameters over on the asset, i.e. the same value in terms of the token drives the same render pass, for example 0 driving diffuse lighting, as long as that's the case, and as long as we add new render passes to our asset, we add new render passes to this parameter, we know that by setting this parameter, if it's driving the asset, we're going to be setting the same pass on the asset. So I'm going to set up our 3 passes. That's 0 is diffuse lighting, 1 is AO, and 2 is fill. And we can now accept this, and if we jump over to our material and bring up the type properties of our material, I'm going to jump over to our render pass parameter, and on the channels tab, I'm now going to set the default value of that channel to the parameter we just set up. So that's /out /render settings /render pass. If we accept this, now we are going to notice if we accept this, look at diffuse lighting. Diffuse lighting is being green now. It's actually being driven by an expression, and if I was to take a copy of this guy as it jumps off the screen, there we go. So grab a copy of this guy and then pin him, and then jump over to out. Fantastic. So here's our null in out, and as we change this null, notice how it's driving our render pass parameter on the asset. Now you may find if you didn't have the default value for render pass set currently and you change the default value, you may find that your asset hasn't updated to be driven by this. If that's the case, if your particular material asset doesn't have this being driven, you can simply make sure when we create a new instance of the asset, so if we create a new instance of our HDRI material, then that would definitely come in with the default value. So if this wasn't set to the default value when we changed what the default value is, we are going to find that this may not be set up and following along correctly. If that is the case, just make sure that you save out the operator type, delete out the existing material, and then bring in a new instance of your HDRI material. And that will just make sure that everything is following along correctly. You'd also need to make sure that it's either named the same if you delete this guy and create a new one as this, or you jump over to the object context and just make sure that we are indeed setting the material of the floor plane and the teapot to this material. In my case, everything is set up correctly and working nicely for us. So what I'd like to do is jump over to out and tear off a copy of the parameters for our null, and then jump over to our scene view, and I want to render a fill pass, for example. And we can see by changing the parameter on our null, that's going to drive the parameter on our asset, and that means when we render, we're going to be rendering that particular pass. So let's just give this a second. There we go, we can see this is the fill pass. If I change this to ambient occlusion and was to re-render, I won't render the entirety of this pass, obviously it's quite a slow pass. We can see this is indeed our ambient occlusion pass. I'm just going to escape to cancel that, close that out. Fantastic. Now, we want to, if I jump back over to out, we obviously want to be rendering using mantra, so I'm going to create a mantra output driver. And what we want to do, I want to make sure that when I'm rendering to a number of different files, and the file name of the file I'm rendering to is being driven by the render pass that I'm rendering. But unfortunately, we can't just grab the value of this channel, because the value of this channel is simply an integer. This has a value of 0, value of 1, a value of 2. We're actually dealing here with a menu where the string name, the human readable name that we're looking at, is not the parameter value. The parameter value is just an integer that's being driven underneath this. So what I'm going to do is create a new parameter on our output driver where we can create an expression that's going to jump in. It's going to grab the list of human readable names along with the list of the numbers that drive them, and then we can basically process that list of information based on knowing the current value of this parameter, and we can grab the human readable name, if you will, of this parameter. So let's jump over to mantra 1, and I'm going to bring up the edit parameter interface, and I want to create a new string parameter. And let's just call this something like render pass. Give this the label of, so name of render pass, label render pass, and accept. And now if we hunt down that parameter, there it is. I'm going to make sure the first thing I want to do is actually set this to the Python expression language. We're going to be creating this expression in Python. I'm going to right click, and currently we're editing the string, we're not editing the expressions. If I go to right-click expression, toggle expression, and then right-click expression, now see how we're editing the expression? And in this expression, we're going to be setting up the way that we can go out, grab the list of information, partition that information, grab just the piece of information that we need, and return that as the string for our parameter. Now, before we do that, I want to demonstrate the basically HScript command that we're going to be calling, that's going to do the bulk of the work for us there. And to do that, I'm going to bring up a text port. So here we are in a text port, and we're going to be using the op menu command. And the op menu command, as this helper is very usefully telling us, it shows the items of a menu parameter on an operator. We need to give it the basically name of the operator we want to work with along with the parameter name, and I do want it to list all of the information, so -l, and I want it to give us the render pass parameter of our /out/render settings node. So it's going to, if we push enter now, list to us a number of entries: 0, diffuse lighting, 1, ambient occlusion, 2, fill. All of this is string information, and when we call from Python, we call this particular command, it's going to return to us a single string. But what do we notice? We notice that each of these is on a different line, so if we break it apart based on the new line character, that's going to allow us to break apart each of these entries. We know that the bit we're interested in is the second entry in the pairs of entries, so we can use the current value to work out which pair of entries we are, and then grab the second entry of that pair of entries, making sure we strip off any white space and the quotes in the string as well. So I just wanted to demonstrate the hscript command that we are going to be calling on, because we're going to be calling this from Python. So I'm going to close our text pot, bring back up our edit expression, and we'll start out by calling that hscript command. And I want to take the result of that command and store it into a menu items variable. So menu items is equal to hscript, because we want to call an hscript command. And what command do we want to call? I want to call on op menu -l /out /render settings render pass. So I want to call the exact same command that we called before, and that's going to return to us that string. So if I was to simply print menu items now and apply this, there we go, we can see what we're getting back, and you can see that we are indeed getting a single string, and that string does have the \n new line character in it. So if we were to split based on the new line character, we'd be able to split the number and the human readable name into different entries in a list. It's worth noting that we actually want to split on the true string \n, not just on the new line character. Notice how the string contains \n, it doesn't contain a new line. So what we're going to do is take menu items, and we're going to set it equal to the menu items. I do want to make sure it is a Python string type, so I am going to cast this over to a string, or rather create a new string object passing in the existing text as the data into our constructor. And I want to call on split, and the string that I want to split on is going to be \n. The \/ gives us a true \/ character as opposed to escaping the following character, and I actually want to split on \n. So \n is going to allow us to split on \n, and if we now print menu items, and let's first clear this and then apply. Notice, it may be very hard to see, but notice we are now dealing with a list. There are square braces on each side, and the entries in our list have been split apart. Notice there aren't any \n's in here either. So now that we have that, we can work out that our menu item is going to be equal to, now we saw that we had pairs of information. That means if I set the parameter to a value of 0, I'm dealing with the first two entries. A value of 1, I'm dealing with the next two entries. A value of 2, I'm dealing with the next two entries. That means I need to take that parameter and multiply it by 2 to move to the start of each entry. However, if I had a value of 0 and I multiply it by 2, I get 0. If I have a value of 1 and I multiply it by 2, I get 2. 0, 1, 2. If I have a value of 2 and I multiply it by 2, I get 4. 0, 1, 2, 3, 4. Notice how I'm pointing at the number each time, and I want the human readable name. So if I take the channel, the current render pass parameter, multiply it by 2, and then add 1 to it, I get 2 times 0 is 0, plus 1 is 1, so 0, 1 gives me diffuse lighting. 2 times 1 is 2, plus 1 is 3, so 0, 1, 2, 3, ambient occlusion. 2 times 2 is 4, plus 1 is 5, 0, 1, 2, 3, 4, 5 gives me fill. So we're going to take 2 times, and notice this is menu item, not menu items, 2 times out render settings render pass, and we're going to add 1 to that. And that means that if we were to jump into our menu items and grab menu item, that would be grabbing the human readable name, but we're going to notice that that's not quite what we want currently. If I was to clear and apply, we are getting AO, but notice we're getting a series of spaces in front as well as quote marks, and we want to get rid of those. So actually, before we return this, we're going to return this value, but I want to strip off of this value any white space, so space, and any quote marks, so \quote, close off the quote to close off the string that we're specifying for what we're stripping. And now if we was to accept this and close, notice if I was to toggle our render pass back over to looking at the result, there is ambient occlusion, and I'm going to tear off a copy of this just so we can see. So there is ambient occlusion, and if I grab our render settings and now change this, diffuse lighting, ambient occlusion, fill, diffuse lighting, ambient occlusion, fill, but now we're dealing with a string parameter. This actually contains the text fill, whereas if we were to reference the value of this particular parameter, we'd simply get back a 2012. So now we have a way of getting the true human readable name of this parameter, and we can use that now in our file name. So now that we have that, on our mantra output driver, we've got our output picture. I'm going to create an image. It's going to be relative to our HIP file. It's going to start with the name testrender underscore, and once we've got testrender underscore, we're going to use the name of our current render pass as the next portion of the file name. So I'm going to use backtick. That is on a UK and American keyboard, it's just left of the numeric 1 above all of our alpha, basically our text letters, Q, W, E, R, T. You've got the number 1 at the top there, and then you've got the backtick next to the number 1. And we're going to backtick channel string, so CHS, render pass, backtick, and that's going to take the string from here and put that into our file name, obviously closing off our file name with .pic. So let me just accept that and then bring that up in a editor so that we can see it's $hip/testrender underscore backtick channel string, our render pass, which is on our current node, so we don't need to specify a node, simply render pass parameter backtick.pic. And now, if we were to accept this, we could go ahead and, based on whatever we had set here, when we render, we take the name from here and put that into the file name. Now, before we go ahead and actually do any test renders, we need a way to easily render all of our passes so that we can loop through each pass in turn and render out that pass. And we're going to do that, as we mentioned earlier, with takes and a wedge drop. So I'm going to switch over to the take list, and I'm going to append a new take under main, and this is going to be our passes take, and it's going to act as a parent to each take that we want for our render passes. And the reason for this is that when we create a wedge drop allows us to specify a parent take, and then it loops through each of the child takes of that parent. I don't want my child takes to be children of main, because then if another artist was to come in and create another take under main for some other purpose, and we were to render using our wedge drop, we'd render that take as well. By specifying a passes take as a child of main, and then specifying a number of takes as children of passes, and then using passes as the parent take when we're dealing with our wedge drop, that means that only passes that get, or rather only takes that get created underneath passes will be rendered. And this is very powerful because we can actually create a number of passes, set them up, and then we can save them out, including their children, to disk. And then we can load them back in, and that gives us an identical copy of the entire hierarchy. What's nice about that is we can make modifications. Maybe we delete a couple of takes that we don't want to render, or maybe we add some additional takes or tweak their settings. Then by simply changing which parent take we're looking at, we can change which set of takes we render out. So very powerful workflows when working with takes in Houdini for render passes. So I'm going to right click and append a take under passes, and this is going to be our diffuse lighting take, and I'm giving this a slightly nicer human readable name because it's simply the name of the take that we'd see up here or on our output driver. I'm going to append another take. This is going to be for our ambient occlusion, and append a final take, which is going to be for fill lighting. We can now, if I jump back over to our render settings, let's set ourselves to ambient occlusion, include our render settings render pass parameter and set that to AO. Diffuse lighting, let's make sure that's included in the take and set to diffuse lighting. And fill, let's include that in the take and set it to fill. So now, when we change takes, we're changing that parameter, and that parameter is driving any instance of our shader asset that's looking at that parameter value. So now if we can switch to each take in turn, and then that's obviously going to set up the correct pass, and we can render out, it's also going to take the name of the pass as we switch takes and use that in our file name. So we could now render, if I switch back to main, I can render individual passes by coming down to render with take and specifying which pass I want to render with. And we could demonstrate this really quick. I'm going to demonstrate this if we set this to fill and render. And that has actually caused a crash. So I'm going to pause the video. I'll be right back after that. Take a look at why we've crashed out. And I'll be right back. Thanks a lot, everyone. Okay, so I'm back, and there really wasn't any apparent reason why Houdini decided to crash. The most interesting thing was that before even loading Houdini again and testing our file, I took a look at the image that was supposed to be rendered, and you notice that the file name was indeed set correctly, testrender_fill, and indeed it actually rendered out correctly. There wasn't any issues in terms of it crashing mid-render. It had completed its render before it crashed. And so I loaded up the file, the temporary file that was saved out when Houdini crashed. That brought us right back to exactly where we were before, and without making any changes whatsoever, I retested the render, and that worked fine, it didn't crash. And then I tested the other passes rendering out, and that worked fine, it didn't crash. Now the one thing you would notice on your end when you rendered and it didn't crash, let's re-render real quick, is that Mantra is going to throw a warning at us, and it's going to throw that warning because we don't have any lights in our scene, and we don't need any lights in our scene because our shader is dealing with the lighting internally by referencing our HDRI image. However, it's telling us that a headlight was automatically added to the scene because we didn't have any lights, but we can go ahead and effectively add the Soho Auto Headlight rendering property to basically tell it to not add a headlight. But from Houdini 10, we don't actually need to add that property, and that's because over on the Objects tab, the headlight creation is that render property. You see, the parameter name is Soho_Auto Headlight. So if we turn that off and were to re-render, you notice we don't get that warning anymore. So all we need to do now is set up a way that we can render all of our render passes, so AO, diffuse lighting, and fill all at once with just a single click of the button, so that we can click that button, it will go away, it will render all the render passes, and then we can come back and composite those passes together. So I'm going to create a wedge drop. So let's actually just drop our parameters down, unpin that. There we go. So let's create a wedge drop. And this wedge drop is going to be driving our Mantra 1, and it's going to be driving it by take. So let's switch down and set the wedge method to by take. And we get to specify a parent take, and we need to specify passes as our parent take. So our parent take is passes. That now means that this wedge drop, when we render, will drive the specified output driver, which needs to be Mantra 1. It will drive Mantra 1, and it will basically set us to each take in turn, and then render from Mantra 1, which means that we'll go to AO and render Mantra 1. We'll then set to diffuse lighting, render Mantra 1. We then set to fill and render Mantra 1. And again, coming back to what I was talking about earlier, we could save out this hierarchy of takes, load it back in, make some tweaks, and all we'd need to do would be to switch over to our wedge drop, change the parent take to the newly loaded in parent, and it would, instead of rendering these passes, it would render the new hierarchy of passes. So a very powerful way of working with render passes in Houdini using takes. So now if I was to click on the render of the wedge drop, we're going to go to each pass in turn, and we're going to render out from Mantra. We do, of course, need to make sure that Mantra is set to render with the current take, because if we're changing our take before rendering, we want to make sure that we are indeed rendering with the take that's being set up. So I'm going to jump to our wedge drop, and I'm going to click render. This is going to take a while to render out, and it can't find the output driver / Mantra 1. Okay, so let's just make sure we export it, not with a relative path, with an absolute path, and re-render. There we go, and that is now working. So obviously the output driver needed an absolute path, not to worry. And we just need to wait for Mantra to render our passes. And it is going to take a couple of minutes because of the fact that we're dealing with rendering our ambient occlusion, we're dealing with rendering our diffuse lighting, and our fill pass, which is really quick to render, but the other two are ray tracing based, and they are a lot more computationally expensive. So that's actually going to go ahead, it's going to render our passes, If we just give that a second to render our passes. So it shouldn't take too much longer to render. And once it's rendered, we can load in each file in turn, double check that the name is being set correctly, double check that our pass is being set correctly as well. So maybe about another minute to render, most likely. But just to recap, what we've done is we've set up a high-level place for driving our render passes, and really you can't get too much more high-level than takes. Takes are very high level in Houdini. And we've got that high level place for driving our render passes, which is driving a sort of just slightly less high level node. In our output context, we've got our render settings null, and that's being driven by our takes. And that render settings null is a placeholder that any instance of our material asset is referencing, and that means that I could create hundreds of instances of our material asset, each with different parameters set, but I know that as long as I have /out/render settings with the render pass parameter on it set up correctly, as long as I have that in place, I can create an instance of a material asset. I don't have to worry about driving its render pass parameter. It's automatically set up and automatically there to be driven by the parameter on our null, which means that every material asset instance in our scene is set to the same render pass when I change this parameter. But our render has just completed, so let's bring up mplay. So let's just give mplay a second to load. There it goes. We are already in the folder for our HIP, and you'll see we have these three files, our testrender_ao.pic, our testrender_diffuselighting.pic, and our testrender_fill.pic. So we can see that our three passes, their names are being put correctly into the files, which should tell us that our render pass parameter was being set correctly for those three files, because our take was being set correctly for those three files. So let's load up each one in turn. So load our ambient occlusion, and this indeed is our ambient occlusion pass. Let's load our diffuse lighting. That is indeed our diffuse lighting pass. And then let's load our fill, and that is our fill pass. So we now have a very nice workflow for dealing with render passes. As soon as we add any new passes to our shader, all we need to do is make sure that we update the menu of our render pass parameter to add an extra item into that menu so that we can switch to the new entry in our switch. And if we update this parameter, we need to also make sure that we jump over and update the render pass parameter on our null. And then if we want to render using takes and using our wedge, we simply come in, create a new take, drive with that new take the render pass parameter to the new pass, and that then allows us to render all of our passes based on takes, or switch over to mantra and simply set us to a single pass to re-render that pass using that take. So hopefully you can appreciate that this is a very powerful, very flexible method for working with render passes coming out of our shader, coming out of our material asset. And that is going to conclude this lesson. And now that we've got that system in place, we can continue adding new passes and adding new functionality to our shader, and each time we add a new pass we can integrate it into this existing method and into our asset, which is why I wanted to get the asset and I wanted to get our render pass management systems in place now, so that as we start adding more and more functionality to our shader, we can set up that functionality to make use of these systems. So that is going to conclude this video. Thanks a lot, everyone.